What's up, everyone? Welcome back to the channel. Today, we're diving deep into a Tesla era code that can seem pretty intimidating at first. P0AA6, the high voltage isolation fault. If you've seen this pop up on your diagnostic tool, don't panic. We're going to break down what it means, how to find the problem, and what it takes to fix it. So, what exactly is a P0AA6 fault? In simple terms, it means the car's computer has detected an electrical leak. Imagine your high-voltage system is like a perfectly sealed water pipe. This code is telling you there's a pinhole leak somewhere, and high-voltage current is escaping from its intended path and making its way to the vehicle's metal chassis or ground. This is a critical safety issue, because you absolutely do not want high voltage going where it shouldn't. The system is designed to be completely isolated, and this fault tells you that isolation has been compromised. Now, where could this leak be coming from? The usual suspects are the major components of the high-voltage system. First, you have the high-voltage cables themselves. These are the thick, bright orange cables you see under the car and in the frunk. Over time, they can get damaged from road debris, rubbing against other components, or even just from age and environmental exposure. A tiny crack or abrasion in the insulation is all it takes for current to find a path to the chassis. Next up is the inverter, or as Tesla often calls it, the drive unit. The inverter is a complex piece of electronics that converts the DC power from the battery into AC power for the motor. Inside, there are tons of components, and any one of them could fail in a way that creates a short to the inverter's metal housing, which is bolted directly to the chassis. Finally, we have the high-voltage battery pack itself. The battery housing is designed to be a fortress, but damage or internal component failure can also lead to an isolation fault. A fault inside the battery is often the most complex to diagnose and repair. So, the three primary locations to check are the HV cables, the drive unit or inverter, and the battery housing. Okay, so we know what it is and where it might be. How do we pinpoint the exact location? This is where the pros break out a special tool called a megometer, or an insulation resistance tester. This isn't your standard multi. A megometer applies a high voltage, typically 500 to 1000 volts, to the circuit to test the quality of the insulation. The process is methodical. First, you need to safely de-energize the high-voltage system. This is a critical safety step and should only be performed by someone with proper training. Once the system is confirmed to be safe, you'll start disconnecting the high-voltage components one by one. For example, you'll disconnect the main HV cables from the drive unit and the battery. Then, you use the megometer to test the insulation resistance of each isolated part. You'd test the cable running to the front drive unit, then the cable to the rear. You'd test the drive unit itself. You're looking for a reading that is below the manufacturer's specification, which is typically in the megaohm range. A healthy component will show very high, almost infinite resistance. A faulty one will show a much lower reading, indicating that current is able to leak through the insulation to ground. By testing each segment of the HV system in isolation, you can systematically narrow down the source of the problem. Let's say your tests reveal that a specific high-voltage cable has failed the insulation test. The fix, in this case, is straightforward. You replace the entire damaged cable. There's no patching or repairing these cables. Safety demands a full replacement. If the test points to the inverter or drive unit, the solution is usually to replace the entire unit. These are complex, sealed components that aren't typically serviced at a component level in the field. And if the fault is traced back to the battery pack, that often means the pack needs to be removed and either repaired by a specialized facility or replaced entirely. To give you a real-world example, we recently had a Model S in the shop with this exact P0AA6 code. The car would drive, but the warning was persistent. After de-energizing the system, our first test was on the main cable connecting the battery to the rear drive unit. We hooked up the megometer, and sure enough, the resistance was way below spec. Upon visual inspection, we found a small section of the cable near a mounting bracket that had been rubbing, eventually wearing through the outer orange sheathing and the insulation beneath it. A new cable was ordered, installed, and after retesting to confirm the high resistance reading was back to normal. The fault was cleared and the car was good to go. So there you have it. The P0AA6 code, while serious, is a solvable problem with the right tools and a systematic diagnostic approach. It's all about confirming the leak, isolating each part of the HV system, and testing with a megameter until you find the culprit. From there, it's a matter of replacing the faulty component, whether it's a cable, an inverter, or the battery. Thanks for watching. I hope this guide was helpful in demystifying this complex code. If you found this video useful, give it a thumbs up. And don't forget to subscribe for more deep dives into vehicle diagnostics and repair.